Okay, good morning, class. So today we're looking at exponential and logarithmic functions. So for this part of for this video, we're going to look at exercise 1. Okay, in this exercise we did the whole exercise. So I'll answer these questions accordingly. Okay. The question 1. Right? Okay, so let's look at 1.1. Question 1.1. So the question says solve for x in the exponential equation. So let's look at 1.1. So we have 2x into 2 to the x minus 2 is equal to 64. So the brackets stand for what? Multiplication. If you're multiplying it based on the same way, add the exponent. So it's going to be x plus x minus 2 is equal to 64 can be written as 2 to the exponent 6. For those of you who don't know how about that, on the calculator, yes, this one I have the fact button. So it's going to be 64 equals shift and you factorize 2 to the 6. Okay. So when bases are the same, exponents are equal, so therefore x plus x is 2x, minus 2 is equal to 6, so 2x is equal to 8, therefore x is equal to 4. And of course you can test it, you can put 4 in here, so it's 2 to the 4 times 2 to the 4 minus 2, which is 2 to the 2. 2 to the 4 times 2 to the 2 is 2 to the 6, which is 64. In any equation you can do that, okay? 2.2, we got 5 to the x times 5, 25 to the 2x is equal to 125. So again, we're going to try and make the bases the same for the exponents to be equal. 25 can be written as 5 squared. The raised to the 2x is equal to 125. Get rid of the brackets there, so it's 5 to the x times 5 to the 4x is equal to 125. So it's 5 to the x. When you're multiplying it, bases is the same, you add the exponents. X plus 4x is of course 5x is equal to 125 can be written as 5 cubed. When bases are the same, exponents are equal, so therefore 5x is equal to 3. X then equal to. Look at 1.3. Is there any issues there? No? 1.3. We got 3 to the x minus 1 times 27 is equal to 1 over 81. So 27 can be written as 3 cubed, not so. However, if you put 1 over 81 and you try and factorize that, it's not going to work. Alright, so what we do is, we write it as 81 first, then we factorize that, which is 3 to the 4. So 1 over 3 to the 4, we bring that up, becomes 3 to the negative 4. When we're multiplying it bases are the same way, add the exponent. So x minus 1 plus 3 is 3 to the x plus 2 is equal to 3 to the negative 4. Now what? When bases are the same, exponents are equal. Therefore x plus 2 is equal to minus 4, which implies now that x is equal to. Okay. (1.4) we got 12 times 2 to the x minus 2 is equal to 192. People, one of two ways I can do this. I can either work out 12 in products of its prime factors, which is 2 squared times 3. But there's no x on here. So I just divide by 12 both sides. As we can see, that's multiplied here. The reason why I didn't divide here, I could have divided by 27 here as well, not so? It would have given you 1 over a very big number there. And then you could have factorized that thing. Here we wouldn't, because there is a variable here. There as well. Okay. So 192 divided by 12? 192 divided by 12, 16. So that's equal to 16, which is 2 to the x minus 2. So 16 can be written as 2 to the 4. Therefore, when bases are the same, exponents are equal. X minus 2 is equal to 4. X is indeed equal to 6. People, is there any confusion there? No? It's fairly simple, no? So in the graphs below, f of x is equal to b to the x for each pair of graphs, answer the following question. Write down the equation of f and g, where f and g are reflections in the x or y axis. Write down the domain and the range, the value of a, the x or y coordinate of the point P on the graph of f or g. Okay, many things are telling us. So let's go from the top. Okay, over there. Little smaller. Alright, so let's go with A. Write down the equation of f or g. So if you're looking at f and g. So f is this graph here, not so. So f of x is equal to b to the x. So now how many unknowns do we need to solve there? One, which is b. So we just need 1 point on this graph other than 0 and 1. If I'm going to put 0 in here, b to the 0 is 1. So that's not going to work for us. So I can't do p because here we got a and 25. However, we got minus 3 and 125. So we're going to substitute minus 3 and 1 over 125. That's the x and a 1. So you got 1 over 125 is equal to b to the negative 3. Not so. So 1 over 125 is equal to b to the minus 3. So one of two things I can do here. Okay, either get the exponents equal for the bases to be the same. Okay, as you can see, the unknown is in the base. So 125 can be written as 5 cubed, not so. So that's b to the minus 3. I could have said that's 1 over b cubed, and then I would have seen that 5 is the same as b. Why bring that up? It becomes 5 to the minus 3 is equal to b to the minus 3. People, lo and behold, b simply 5. Can't believe it's so easy. Upset. No? It's so easy. We're looking for that challenge in our lives. No? Of course. Yeah. Otherwise, what are we living for? No? People, the question says, write down the equation of f. So we've got f of x is equal to 5 to the x. People, g of x is a reflection of f of x in the line. X equal to 0 in your y, in the y axis. So if something is reflected in the y axis, what do we do? X becomes negative. So if something is reflected in the y axis, x becomes negative. Okay. So in other words, y is equal to 5 to the minus x, or 1 over 5 to the x. And this is the g of x graph. Okay. Let's look at b. B says write down the domain and the range of f and g. Domain. Range. So let's look at the domain of f. Murph is going negative infinity, positive infinity. So x is an element of R. Let's look at the range. Does this graph exist at negative infinity? No. Where does it start existing at? 0 onwards. So y is greater than 0. Let's look at the domain of g and the range of g. The g is the red graph now. What do you notice? A graph going negative infinity and positive infinity. Not so. So what do I say? X is an element of R. Let's look at the range. Does this graph in the red exist at negative infinity? No. Where does it start existing at? 0 onwards. So y is greater than 0. Right, let's go to the next part of the sum. The next part of the sum says, find the value of A. So there is A. The x or y coordinate of point P on the graph of f or g. So that is on the graph of f. So I can only use f's equation. So f of x is equal to 5 to the x. So what I do is I substitute P, which is A at 25. That's the x and a. So 25 is equal to 5 to the a. So 25 can be written as 5 squared. So therefore a is equal to. Okay. Is there any confusion, people? Right, let's go to the next one. Two point 2.2. Wait. Let's cut first, probably before that. Huh? Right, here we go. 2.1. 2. Try and keep it as big as possible. Okay. People? Hey, I asked to write down, or to write down the equation of f and g. Remember, f of x has the formula b to the x. I think that's the part I cut off there on top. Okay. So, how many variables do we need to solve here? 1. Remember, this is 2.2. No? There's one variable we need to solve. I need 1 point on the graph other than 0 and 1. Do we have such a point? Yes. We have 2 and 4. Let's substitute 2 and 4. So let's say x and a y. So we say y, remember f of x is a y is equal to b squared. Sorry, 4 is equal to b squared. So how do I get rid of the square? Square root. If I introduce square root, plus minus. But what do we know about b? B has to be positive, yes. So therefore b is equal to 2. Why? Because b must be positive. B must be greater than 0. Okay. Otherwise you could have said that's going to be 4 is equal to 2x. So 4 is going to be 2 squared is equal to 2 to the x, therefore x equal to 2. Same story. Okay. So f of x now reads f of x is equal to 2 to the x. But then they want g of x as well. People, g of x is what? In relation to f of x. Is it reflected in the? If something is reflected in the x-axis, what happens? Y becomes negative. So it's negative y is equal to 2 to the x. Divided by negative, so y is equal to negative 2 to the x. And this is the equation of g of x. Okay. People, what is the domain? Yeah, domain and range. Domain of G, the range of G. So G is the graph in red. The domain is all possible x values. What do you notice? Negative infinity, positive infinity. Not so. So what do I write? X an element of? Let's go into negative infinity. So it goes negative infinity. Where does it stop existing at? 0. So anything less than 0. So y is less than 0. Let's look at the domain of f and the range of f. You see the graph is going to negative infinity, positive infinity. Not so. So what do I say? X is an element of real numbers. Does this graph exist at negative infinity? No. Where does it start existing at? 0 onwards. So y has to be greater than 0. Okay, you guys understand? Any confusion there? Next question. Find the value of a. Right. Where's a? Yeah. But a is lying on f of x. So we're going to substitute p, which is negative 4 and a, into f of x. And only going to f of x. Alright, so let's say x and a 1. So a is equal to, remember that's the equation. That's the y. A is equal to 2 to the negative 4. And 2 to the negative 4 is 1 over 16. No? 1 over 16. Okay, the sum just gets easier and easier. And that's why she likes this section, huh? Numbers point? You like easy stuff? Do you think the great mathematicians of the past enjoyed maths because maths was easy? Huh? Sorry? What's he say? That I don't think that's the reason why they enjoy it. It's probably because it was nice and challenging. Right, let's look at the first one. A. Write down the equation of f and g, where f and g are reflections in the x and y axis. X or y axis. Right, so where do we go? We start with R. F of x is equal to b to the x. So if we look at f of x, what do we notice? We have 1 point on the in order to calculate b. So we'll sub negative 2 and 9 over 4. That's x and a y. So 9 over 4 is equal to b to the negative 2. So what do I do now? That is going to be 1 over b squared. Not so. Whoops. What's wrong with the marker today? Which is 9 over 4. Cross multiply. So 9b squared is equal to 4. B squared is equal to 4 over 9. How do I get b on its own? Square root. Or I can write 4 over 9 as 2/3 squared is b squared. So therefore b is equal to 2 over 3. B has to be positive. No? So what's my equation of f of x? It's going to be 2 over 3 raised to the. What is g of x? G of x is the reflected in x-axis. What's the rule if something is reflected in x-axis? Y becomes negative. So f of x is the y, not so. The negative y is equal to 2 over 3 raised to the x. Divide by negative both sides, so y is equal to negative 2 over 3 to the x. And this is the yes. Right. Let's go with B. Write down the domain and the range of f and g. Write down the domain and the range of f and g. People, the domain of f. Domain is all possible x values. Goes negative infinity and positive infinity. So what do we say for that? It's the element of order. Let's look at the range. Does this graph exist at negative infinity? The one in blue? No. Where it starts existing at? 0 onwards. So y is greater than 0. Can be equal at 0? Why not? Because yes, is not a never touching yes, which is called what? An asymptote. The d of g, r of g, the domain and the range of g. The g is the graph in the red. Does this graph exist at negative infinity? Yes. Positive infinity? Yes. So x is an element of all real numbers. Let's look at the range of g. Goes negative infinity. Where does it stop existing at? 0. So in other words, it has to be. So y is less than 0. Right. Next, C. The question says, find the value of A. Where's A? A is lying on the graph of G. So I can only use G. So I'm going to substitute P, which is negative 2 and A, into G of X. And G of X is negative 2/3 raised to X. So this is a X and a Y. So a is equal to negative 2 over 3 raised to the negative 2. Of course, the negative must sort out. So that's simply going to be 9 over 4 in the negative. No? So you say negative, from brackets, 2/3 raised to negative 2. Negative 9 over 4. So a is okay. I can't believe it's so easy. Okay. I think I must give my grade 11s this exercise. No? Just to keep the juices flowing in their heads. Sorry? In the exam. Because you're not in grade 11 anymore. I think I should. Let's see. But some of them are fairly good in graphs. Sorry? Sorry? Bonus question. No, this is basic. This is not bonus. This is not bonus. This is basic stuff. These things you need to know from grade 11. Sorry? It was supposed to be easy. No, Michael. Okay. Yeah, but then again, all things in maths is easy. That brings us to the end of exercise 2.